Hey guys, what's up? This is Manoj sir, and in this video we are going to solve second problem from the topic Fourier series. Okay, so the problem says obtain a Fourier series for f of x equals to e to the power minus x in the interval 0 to 2 pi. Okay, so here if you see f of x is given as e to the power minus x and b minus a. Okay, that is, this upper limit is b and this lower limit is a. This is nothing but your 2 pi. Okay, therefore the Fourier series for f of x is given by. Now if you see, the formula for Fourier series is this, that is f of x equals to a naught upon 2 plus summation n equals to 1 to infinity a n cos of 2n pi x upon b minus a plus summation n equals to 1 to infinity b n sin of 2n pi x upon b minus a, where we have the formula of a naught a n b n by the help of Euler's formula is this. Okay, but here we are having b minus a equals to 2 pi. So if you put b minus a equals to 2 pi, so the Fourier series this becomes f of x equals to a naught upon 2 plus summation of n equals to 1 to infinity a n cos nx. Okay, if you put b minus a equals to 2 pi here, so 2 pi gets cancelled. Here you will be left with cos of nx. Okay, cos of nx plus n minus 1 summation n equals to 1 to infinity bn sin nx. Okay, where a naught equals to 1 upon pi integration a to b f of x, a naught equals to 1 upon pi integration a to b f of x cos nx dx, bn equals to 1 upon pi integration a to b f of x sin nx dx. So we are going to use this formula. Okay, so f of x, which is nothing but e to the power minus x, this equals to a naught upon 2 plus summation n equals to 1 to infinity a n cos nx plus summation n equals to 1 to infinity bn sin nx. And let's suppose this is my equation number 1. Okay, so we are going to find the value of a naught, a n, b n one by one. A naught equals to 1 upon pi times a to b f of x dx. Okay, now put the values 1 upon pi, limit goes from 0 to 2 pi, e to the power f of x is nothing but e to the power minus x dx. Okay, now integrating this part, that is e to the power minus x, you will have 1 upon pi e to the power minus x upon minus 1. Okay, limit goes from 0 to 2 pi. Okay, taking this minus 1 out of this bracket, you will have minus 1 upon pi, put upper limit, that is e to the power minus 2 pi minus e to the power 0. Okay, now since we have negative, so take negative from this, we will have e to the power 0 is 1 minus this is e to the power minus 2 pi upon pi. Okay, so this is the value of a naught. Okay, now we will try to find the value of a n, which is very important. Formula is 1 upon pi integration a to b f of x cos nx dx. Okay, 1 upon pi, limit goes from 0 to 2 pi, f of x is e to the power minus x cos nx dx. Okay, now here we are going to use a very specific formula, that is use formula e to the power ax integration e to the power ax into cos bx dx equals to e to the power ax upon a square plus b square a cos bx plus b sin bx. We are going to use this formula. Okay, fine. If you compare this with this, you will have a equals to minus 1 and b equals to n. Here a equals to minus 1 and b equals to n. Okay, so a n becomes 1 upon pi. This will become e to the power minus x upon minus 1 square, that is 1, plus n square, that is n square. Okay, now here a, that is minus 1, so minus of cos nx plus b sin n, b sin bx, that is n sin n x. Okay, now limit goes from 0 to 2 pi. Okay, fine. Now we have to open this bracket. Okay, and writing this term here and this term here, so we will have 1 upon pi, taking this 1 up 1 plus n square out of this bracket, 1 plus, take this 1 plus n square out of this bracket, we will have, this is n e to the power minus x sin n x, then write this term, that is minus e to the power minus x into cos n x. Okay, limit goes from 0 to 2 pi. Fine. 1 upon pi times 1 plus n square. Put upper limit, you will have n e to the power minus 2 pi sin 2n pi. Put lower limit, minus n into e to the power 0 sin 0. Okay, now now second term, put upper limit, e to the power minus 2 pi cos 2n pi. Upper limit is negative, so lower limit will be positive. Now this will become e to the power 0, this is cos 0. Okay, fine. Since we know that sine of 2n pi is 0, sine 0 is also 0, so we are having 1 upon pi into 1 plus n square. Writing this term first, that is e to the power 0 is 1 and cos 0 is also 1, so this is 1 minus, then write this e to the power minus 2 pi cos 2 n pi is also 1, so this is the value of an. So this is the value of an. Okay, for bn we have 1 upon pi integration limit a to b f of x sin nx dx. 1 upon pi limit 0 to 2 pi fx is e to the power minus x sin n x dx. Okay, again we are going to use a very specific formula to solve this part, that is integration e to the power ax into sin bx dx. This is equals to e to the power ax upon a square plus b square a sin bx minus b cos bx. Use this formula. Okay, if you compare this with this, you will have a equals to minus 1 and b equals to what? N. Okay, so we will have a n equals to 1 upon pi times, this is e to the power minus x upon minus 1 square is 1, n square is n square. Okay, fine. Now a is minus 1, so we can write this as minus sin nx minus n cos nx. Okay, limit goes from 0 to 2 pi. Now taking negative common, minus 1 upon this part, we are taking this part out of this bracket, we will have pi times 1 plus n square. So we are left with e to the power minus x sin nx plus n times e to the power minus x cos nx. Okay, limit goes from 0 to 2 pi. Okay, in this step we are going to put this limit, that is minus 1 upon pi times 1 plus n square. Put upper limit, you will get e to the power minus 2 pi sine 2n pi. Okay, put lower limit, minus e to the power 0 sine 0. Now come to this part, put upper limit, n into e to the power minus 2 pi cos 2n pi. Now put lower limit, that is n into e to the power 0 cos 0. Okay, since we know that sine of 2n pi is 0, so this part becomes 0, and sine 0 is also 0, so this part is also 0. We are left with only two terms. Okay, write y minus 1 upon pi times 1 plus n square. Okay, n into e to the power minus 2 pi cos 2n pi is 1. Okay, now come to this part, that is n times e to the power 0 is 1, cos 0 is also 1, so this is minus n. Okay, again taking minus common, you will have 1 minus, okay, take n common, you will have 1 minus this part, that is e to the power minus 2 pi upon pi times 1 plus n square. So this is the value of Bn. So we have the value of Bn, okay, as this. Also we have the value of A naught equals to this, and An as this much. So we can write the Fourier series of f of x, which is this, from equation 1. Okay, so we can rewrite from equation 1, we have e to the power minus x equals to 1 minus, here we have a naught equals to 1 minus e to the power minus 2 pi upon pi. Okay, so here it is e to the power minus 2 pi upon pi, but in the series we have a naught upon 2, so write 2 here. Okay, now plus summation n equals to 1 to infinity, we have the value of a n equals to this much. Okay, writing this here, that is 1 minus e to the power minus 2 pi upon pi times 1 plus n square into cos nx. Okay, again we have the value of Bn here. Okay, so plus summation n equals to 1 to infinity, write this part, that is n times 1 minus e to the power minus 2 pi upon pi times 1 plus n square into sine n x. Okay, so this is my final answer. Okay, or you can say like this is the final Fourier series of this function, that is f e to the power minus x. So if you like this video, then don't forget to hit the like button, and please share this video with your friends. Thank you so much.